Welcome back. In this module, we're going to learn how to differentiate the logarithm function. In the last module, we learned that the log function y equals ln x is the inverse function of the exponential function y equals e to the x. It turns out that the derivative of ln x is 1 over x. You should commit this to memory. Using the above fact, let's try and differentiate the composite function y equals ln of x squared. By setting the inner function u to be x squared, we can therefore write y in terms of the variable u. That is, y equals ln u. The chain rule then states that the derivative we seek, dy dx, is equal to dy du times du dx. From the equation y equals ln u, we therefore have dy du to be 1 on u. And from the equation u equals x squared, we therefore have du dx to be 2x. And so the derivative is equal to 2x on x squared, which simplifies to 2 over x. Alright, it's time to pause the module and have a go at these practice questions. You will need to use the fact that the derivative of ln x is 1 over x, along with already learnt rules such as the product and chain rules. Here are the answers. We know that the derivative of ln x is 1 over x. But more generally, what about the composite function ln of f of x, where f is any function? Given enough experience with the chain rule, the following pattern can be observed. That is, the derivative of ln of f of x is equal to the derivative of f divided by f itself. This shortcut will make differentiating composite functions involving logs much simpler. However, you should never forget that this shortcut comes from the chain rule. Indeed, the formula is obtained by letting the inner function u to be the function f itself, which allows us to write y as ln u. Let's try using this shortcut on the composite function y equals ln of x squared, which we differentiated earlier on in the module. Here, our inner function f of x is x squared, and so f dash x is 2x. Hence the shortcut tells us that the derivative is f dash over f, which ultimately gives us 2 on x, as we had worked out earlier on. Here's a brief summary of what we've learned in this module.